I shouldn't really say that, but
No,
we
we
do.
don't. We don't need toxic. Toxic is the same as acid.
We're going to come on to that in a bit. Hold on, hold your horses on that. Right, I'm zooming in. Concentrate, Alf. This is the most difficult lesson we've had. I'm going to show you a bit of that membrane. All right, zooming in. Now, let's look at the water first of all. The water I'm going to do with these dots here. You watching? Can you
Yep.
see that?
Dot, 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 dot. Yes.
Right, now
They
I'm
always
doing
change color.
Alvin, shush, I need you to concentrate on this bit, mate. Seriously, this is really top trickiness. So, where is there more water atoms, on the left or the right?
Left.
On the left. So, where is the water going to go?
Right.
That's right. The water is going to go that way. And that process is called osmosis. What's it called?
Osmosis.
Now, if there's more water particles on that left-hand side, that means that there are less of whatever it is that's in the water. Let's say it's sugar, or let's say it's
Salt.
salt. Very, very good. So there's going to be less of those. There's going to be more salt or sugar on the right. Okay.
Yeah.
Now, in what direction will the salt go?
Left.
The salt will go left, but there's a problem. Look what happens when I try and move that salt over. Well, I try and move the
It
salt
doesn't
and
fit.
it doesn't fit. You've nailed it. I can't even move it, unfortunately. Let me make it a bit bigger. I should be able to move it then. It doesn't fit. It won't go in, will it?
No, it won't.
So osmosis is the movement of water from the left to the right through
All
the
from the right
cell
to the left.
membrane. Yes, but it's only the movement of water that we're interested in with osmosis. Diffusion is any particles. Osmosis is just water. You got me?
Yeah.
Was that a yawn, little elf?
It wasn't.
You can't yawn when I'm teaching you about osmosis. Osmosis is really important. Let me tell you why. If you've got a plant that's got a root hair, so this is in
What's
the
a
root.
root hair?
Well, it's in the roots. If you draw a
Plant.
plant like this, so here's your plant with its leaves and stuff, yeah?
Yeah.
And there's its root. If you look at its root hairs, because it's got hairy legs as a plant, a little bit like Daddy, yeah? And
Like
the
spiders.
oh, thanks for mentioning spiders. I hate spiders. Ooh, no one looking around as a spider. Um, if you
There's a
look at the
giant spider behind you.
stop now. Um, if you look at the root hairs, the water gets into the root by osmosis. Why is that important, do you think?
Because of the water.
Plants need water, don't they? Yeah.
Yeah, but plants don't eat salt, so it's probably gonna die.
Plants need some salt, you know,
Oh.
but the salt is dissolved in the water. So that is what osmosis is. It's the movement of water, and the water goes from a more concentrated salt solution, because there's more salt there, to a less concentrated salt solution. Or sorry, it goes from a less concentrated salt solution to a more concentrated salt solution through a cell membrane.
Any concentration?
Yeah. So it's the movement of the water, mate. That's the way, that's the important thing. So we've done 2 of 3. Let's just recap. What's the name of the process by which particles randomly move and spread out? What's that called? Begins with D.
Division. Definition.
Last chance. Dear, you're going to have to shout it 5 times loudly again.
Oh no. Please.
Diffusion. There you go. 5 times loudly. Annoy the neighbor again.
No.
All right, just once. What is it?
Diffusion.
Good boy. So diffusion. Now, diffusion is just that movement of any particles, right? If it goes through a cell membrane, and if it's water, what is that process called?
Osmosis.
Good lad. You're so clever. What are you? Super
Clever.
clever. And you played football today. What was the score?
7-3.
And how many goals did you score?
7.
That's mad. What a performance. Anyway, the third type, I'm going to draw another cell membrane, just like you get on
Higgs.
the border of a cell.
Hypothesis.
Yeah, sometimes, can you say this? See if you can say those 3 words.
Yeah, but the thing is, they're too small.
You can read that.
No, I can't. Selectively permeable.
Selectively permeable.
Membrane.
Okay, well done. Selectively permeable membrane. Now,
Selectively permeable membrane.
this is the third one, Alf, right? So the first one was called what?
First one was called diffusion.
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 The second one was called.
Osmosis.
Right, now this is the third one, and it is called.
Hypsosis. Active transport.
Right, now I'll let you into a secret. Inside the membrane, remember, this is a membrane just like you have in the cell. It's this bit that we're looking at a little bit more
cell,
closely.
mitochondria, ribosomes, and nucleus.
You can take next week's lesson. Inside the cell membrane, you've got things here, and these are called.
Active transports.
No, hold on. These are called carrier proteins.
Protein is healthy, so we must eat the carrier proteins.
Good question. Good point. Protein is healthy, what you eat, but these are tiny little bits of protein, right?
Yeah.
And what they do, and it's really clever, is they take, for example, let's suppose we've got some of that salt that we were talking about earlier.
Yeah.
Yeah.
They own their bodyguards to see if there's any death.
Here's the salt. Now, hold on. Let me just do that there, and let me do that there. Now, what we want is we want to move the salt in this direction. We want to move the salt that way. Now, normally, think carefully, Al. Think carefully about this. Normally, would those salt atoms move that way because of diffusion? Can that happen?
No.
Why not?
Because they're too big to fit in.
They're too big. And also, remember, diffusion doesn't matter about that. Also, there's fewer there than there are there. Diffusion would mean that they go that way, wouldn't it?
Yeah.
Right. But these carrier proteins do this. They take an atom and they bring it in. They tug it in like that. They take that one and they pull it in. And they need energy to do this. And that's why we say
yeah. I understand.
active. Good lad. That's why it's
like they take it
active
from
transport.
the other side.
Yes. And it takes energy to do that. So that's the third sort, and it's not to do with water. The water, don't forget, is still there. You know, if you've got something that's dissolved.
I know what's the next one.
No, there's only 3, fellow.
Hypothesis. I was going to say so.
No, there's only
Active
three.
transform. Oh my goodness, I forgot the second one.
You're so clever. What's the first type?
Definition. Diffusion.
Shall I tell you how to remember it? Just think, phew,
You. That's right.
diffusion. Just like when that toilet that you use in the mornings, diffusion, right? Okay. The second one, what was the second one?
I forgot that one. Optimism.
Osmosis. And the
And
third,
the active transport.
very good. Do the three again.
Diffusion.
Yes.
Uh, um, opposition.
Osmosis. And the third one?
Active transport.
Oh, really good. Which is the one that needs water?
The O one.
Osmosis. Very good. Which is the one that has carrier proteins?
Active transport.
And which is the one that is just doesn't need a cell membrane?
Diffusion.
Love you.
Bye.
I said I love you.
I love you too.
Oh, what are you doing? Well done, Al.